So let me get this started. Can you confirm that you hear me and you can see the screen with the slide?
Yes, everything is
Great.
okay.
So thank you, Giuseppe, for the introduction, and welcome everyone to this webinar that will do. It's an introduction of the EGI Cloud Compute Service. I will deal mostly with two topics. The first one is the EGI Cloud Compute Service itself. So what can it do, how you can use it, how you can become a user, and some few use cases of people that are already using the service for the day-to-day computing needs. And then I will go to describe a bit the infrastructure behind that service, which is the EGI Cloud Federation. I will cover a bit the different components, the architecture, and how, if you're interested to become a provider, how this can be done. At the end, we will have some time for Q&A. So let's get started with the service. Before getting into the service itself, I like to say a few words on infrastructure as a service, as I understand not everyone may be aware of what it is. So very briefly, infrastructure as a service is a cloud-based service that gives you the possibility to run computational workloads in the form of virtual machines, where the user decides what to run, so the operation system and any other software, and how to run it, meaning the hardware that will be used for that virtual machines, the CPU, the memory, the disk, etc. Normally, you start from a virtual machine image, which is the software you want to run, and you add some context and decide the configuration you want to use, so CPU, memory, and disk. And with that, you create an instance of a virtual machine that is the thing that runs and will execute whatever you need to execute. Once destroyed, the VM is gone forever, so you may want to add some block storage to add persistency, which can be thought of some sort of USB stick that you can attach to your VMs as needed. All of this is provided via APIs, so as a user, you are in total control of the compute resources, where they are started, when they are started, the configurations and everything, so you can scale up and down your computing infrastructure to meet the workload demands. So that's infrastructure as a service in a very short intro, and that's what we provide with the EGI Cloud Compute Service. This is a distributed infrastructure as a service powered by the EGI Federated Cloud. And the idea with this service is that large, or well, doesn't need to be large, but international collaborations can perform distributed data analysis across providers all around Europe with virtual machine-based workloads. The main features are listed here. Of course, we can, or you can execute virtual machines on this infrastructure, but it's not just that. We also have federated identities, so you can log in with your institutional credentials. We have a common virtual machine image catalog, meaning that you can have your software in any of these distributed infrastructure providers without worrying on how to make that possible. You have access via graphical user interface and a web dashboard, but you also have command line or API-based access. We have support for orchestration at the infrastructure as service level, and we also have central accounting and monitoring. So we have a central way to control the usage and how the providers are performing in this infrastructure. So that's the service. I will go now a bit in depth on the different characteristics of the service, and I will focus on the different access layers that we have. I will start from the bottom, which is the direct access to different providers. So we have a set of 21 providers right now. All of them are running OpenStack, but we don't have a requisite of running OpenStack. It just happened that providers have converged to this platform during the last years. So we have a set of providers that any developer advanced use can log in using their institutional credentials, thanks to check-in, this vertical box that we have on the right, and can interact directly with the APIs to create VMs, reboot them, resize them, do whatever they need to do with those. So that's the lower level, the direct API access to the providers. On top, we have what we call the federated access that is done via orchestration. And here we have tools that allow you to interact with several providers at the same time and provide some uniformity to the heterogeneous providers that you have below. So again, this is targeting developers and advanced users who want to have quite a lot of control on what they want to do. And in this case, just using this kind of tools to avoid having to deal with the low-level details. And on top of all of these two layers, we have the graphical user interface access, which is powered by the AppDB VMOps. I will show you later how this interface works. And it's mostly targeting the, let's say, less tech-savvy users or graphical user interface users that are just interested in creating VMs and interacting with them in a rather simple way. So let's go with all of them. I will first say what check-in is. So check-in is our authentication and authorization service of EGI. It provides federated identities, so you can log in with Edugain or lots of social media and other institutional community managed identity providers. So basically you have here almost any university in Europe, and you have, well, any kind of, let's say, social media like Facebook, Google, or things like GitHub or Bitbucket. So you have lots of ways of logging into the infrastructure. Thanks to check-in, we have harmonized authorization information. So check-in is able to talk to different user community membership management system and take from them information about you. So about who you are and what groups do you belong to, and put all that information together so the service provider, the cloud, at the end can decide whether you can be authorized or not to enter. And all of this is done using the OpenID Connect, which is an industry standard that allows both web and not web based access to the service. So let's get to the lower layer that would be going directly to the infrastructure as a service providers. Here I'm showing you the graphical user interface dashboard of the OpenStack, and I'm logging into that dashboard with my check-in credential. This is running at CESNET, one of the providers of our infrastructure. I'm getting asked by check-in what's my institutional identity that I want to use. I will use the EGI one, so I'm entering my credentials, and now I will get authenticated. Check-in will say, okay, your credentials are valid, and will ask me for consent. Are you okay with providing information to the service about yourself? I will click yes, and then I will get into the provider dashboard. So there I can do whatever I need to do with the virtual machines. Here it's just showing a summary of what I have started there, but I can do whatever operation I want there. So that's the graphical user interface, but we also have access via the command line interface or API. And for that, we have developed a tool, which is the EGI CLI, which is very simple tool that makes it easier to authenticate and discover what's available to run in the EGI Cloud. It's available in GitHub, and I have a video to show you a bit how this works. It's quite simple, but I think it's also very useful. So here I have my environment ready with some variables related to my check-in user. So this is basically identifying myself as my credentials into check-in. I have a set of secrets that I showed you partially here. And with that and the EGI CLI command, I can discover what are the different providers in the infrastructure. So this is listing them. And for each of them, I can see what are the projects, which are the groups in the OpenStack terminology I can have access to. So I will just check for CESNET MCC, which is what I showed you before in the dashboard, what are the projects I am allowed to enter. And here you can see I have some of them. And with that, I can get the right environment for OpenStack command line interface to interact with. So that's what this last command will do. Now it will show a list of environment variables that OpenStack clients need to make things work. And I can do an eval of that so I can have everything on the shell. So I don't need to copy paste or type anything. And once that's completed, I can interact with the provider with the regular OpenStack commands. In this case, is listing the virtual machines I have running there, and it will show one in a second. There it is. So, sorry. Well, I just show that it show the. I will. Here you can see the VM, and I can do or other operations like listing the configurations I can use for running different VMs. So you can do whatever you want with the OpenStack command line, just using this helper, the EGI CLI, to get that started. On top of this lower layer, we have the orchestration, and here we have different tools that allow you to manage the heterogeneous providers. So we have mainly two, but we are open to others. It's not a closed set, and basically anything that works with OpenStack will work easily here. The first one is Infrastructure Manager. This is a tool developed by the University Politecnica of Valencia, and allows to deploy resources on all kind of providers, including OpenStack, which is our main target here. It uses the Tosca standard for describing the resources, and has nice integration with different EGI Cloud features like the catalog and the authentication. And we will have a webinar on June 24th on that, so I invite you to check the webinar in the next day, so you can learn more about it. And we have other tools like Terraform, which is a tool developed by a commercial company, but it's an open source tool. Again, it supports a lot of different providers, including OpenStack, so it can be used easily with the EGI Cloud. And this is kind of lower level that I am, so it's near API level, but it's quite useful because it makes you interact with all the providers in a uniform way. So it can be really helpful for some use cases. So both of them are working fine in the infrastructure. You have documentation on how to use them in our EGI Cloud documentation, and invite you to check them and use them for your use cases. On top of this, we have the higher layer of interaction with the EGI Cloud, which is the AppDB VMOps. But before getting into that and show you a video how this works, I want to show you just two things that make the EGI Cloud Compute Service work nicely for communities. The first one is the Appliance catalog, which is part of the AppDB, this applications database of EGI. This is mainly a registry for virtual appliances, which is a virtual machine image with some extra metadata about the image. For example, the author, what kind of software is there, what are the requirements in terms of CPU or memory that it needs, or regarding network, etc. And basically, you can publish your images, and they are available for downloading and available to make them run at any of the providers or on any hypervisor. The catalog is not just that, it's also a set of tools to do community level management of those appliances. So each community can manage their own list of appliances and decide which ones are available to run on the providers with exactly covering their needs. So they can have a good control of what can or cannot be executed on the EGI Cloud. And here is shown a screenshot of the interface to manage this image list that we call it. So here I'm showing so the community is vo.access to EGI.eu, which is a piloting community. And here I have a list of images I can use, and I can click on add or remove. And once I click on add, it will be automatically propagated to all the providers that support that community. And if I click on remove, it will be deleted from those providers. So you are in total control of what's available to run on the different providers supporting your community. Besides this AppDB appliance marketplace, we also have a quite useful tool, which is the EGI Cloud Dynamic DNS, that allows you to have DNS names for your virtual machines. This is very useful because IPs are not meant to be always the same. When you start a VM and you start it for a second time, you may have a different IP. So having a name makes you have a fixed thing that you can refer to in your deployments. It also makes it easier to move from one provider to another, because the IP will change for sure in that case. So if you keep the name, you just redirect to the new IP and that's it. And also allows you to request certificates for your services, which is really nice to provide some extra level of security if you are providing any kind of, well, any kind of service to the outside world. So I will show you now a short video on how the catalog, the AppDB VMOps, which is this graphical user interface, and this DNS thing works together to launch a VM that will just have a server, an HTTP server saying hello world, basically. So I'm starting the video. This is the AppDB VMOps. I'm already logged in, so I can create a new topology. I will search the image that I want. So in this case, it's an EGI Docker. I will stop the video for a second. So I selected that image, and now I'm shown what are the communities or virtual organizations in our terms that support that image, and I am a member of. So I can, sorry. I was expecting that this will continue, but so I will not stop it again. So I select the Docker, I can select the community I'm using, in this case a training, the provider I'm using, the size of the VM, and now I can customize further the deployment. In this case, I will call it webinar, VM1, whatever, and I can add some commands to execute. In this case, I will do a registration of the VM into this dynamic DNS and run the Docker container, which has my web server. So now it's being sent to the infrastructure, to Catania provider. It's pending. Now it's running. So you see I have a public IP. I can get the details. I have also some credentials I can use to access the VM. I will download this SSH key for doing that. And I will go now to the terminal on my computer, first to check if the DNS was properly set. So apparently, yes, it's the same IP, so this was working fine. And now I will use the SSH credentials I just downloaded, put the right permissions on that, and do an SSH to the IP of the VM to log in. So just copy paste the IP, and I'm in the virtual machine. I can do whatever I want into that. I will just list the list of running Docker containers, which is this web server I told you. It's a very simple one, and I will check now in the browser that this is up and running. It's just a hello world for this example. So as you have seen from the very web simple dashboard, I can start VMs, I can browse the different images available, I can select the size of the VM, I can select the site, the provider that is supporting that, and I can also get credentials to access the virtual machine and do whatever I need to do on that. So I hope with all of this you are willing to become a user and get started with this. Here in this slide, I have what you need to do. So basically, you just need to go to the EGI marketplace and request access. We have, let's say, two phases. A first one would be a pilot allocation where you can prototype, validate your application during 6 months. This is open to any researchers in Europe. It's a limited amount of resources with opportunistic access, so it may not be available for very large tests, but for sure for piloting it should be enough. And in this case, from EGI, we will support you for creating the virtual appliances, interacting with the provider, solving technical issues, or wherever it's needed from our side. Once you're happy with this pilot phase, we can move to production, where we do a matchmaking between your needs and the providers of the federation, and we establish an SLA that will state what are the resources and the conditions of access for those resources, and we provide you the services following IT service management processes with the FIT-SM standard to ensure that we meet the agreed availability and reliability levels. So this is one slide that just shows that process. So from your requirements, so what do you need, the type of resources, the number, the size, the what can you pay or not, and what are your availability needs and so on. So we go to the providers, negotiate with them who can support you, and with all of that, we create operation level agreements that will specify how the different providers support your needs, and we will have a service level agreement that will specify exactly what you will get from the infrastructure and under which conditions. Right now, we have been running the EGI Cloud service since 2015. So it's been already a couple of years. And since then, we have delivered more than 8,000 CPU years. We have constantly running more than 450,000 virtual machine instances, and we are supporting all kinds of disciplines. The main ones are in the natural science domain, and inside the natural science domain, I would say the bioinformatics, medicine, health are the dominant ones. So we have things like LifeWatch, BioEC, NBIS, Biomed, VNMR, and others. We have also strong usage from the Earth observation domain. We have things like Nexio, Senso, the GeoHazards thematic platform, Geos, and others. But it's not limited to that. We have things like OpenCoast, which is in the environmental engineering, humanities with Clarin and PitchNote, and we have also a lot of training and piloting activities going on. Just to give you some ideas of what we can or what we are supporting with the EGI Cloud, I have 3 slides on different use cases. The first one is DODAS. DODAS is a platform as a service that creates on-demand cluster to execute software applications. So it will use several of the EGI Cloud providers to build a single cluster where you can execute jobs. In this case, we use it to support the CMS LHC experiment, and we created a CMS Tier 3 site on the EGI Cloud. So you can see here a lot of jobs running on this virtual infrastructure, and it's not very easy to see, but the second one here is the T3 IT Opportunistic DODAS. That's our site as seen from the CMS dashboard. So it's contributing to a 12% to the computing done in the period that this screenshot was taken. Another example is this one, which is quite nice because it's a kind of hybrid cloud approach. We are joining here providers from the EGI Cloud with providers from the commercial sector, being GeoHazards and EODC. And here we have a use case that it tries to do big data analytics of some Earth observation data, trying to understand how the land is used for agricultural studies. And it does a lot of analysis with very big images, doing downloads the images, storage them, process them, and that's the analysis. And it's right now is focusing on some parts of Europe, but we are looking towards scaling this to a European continental scale. So you can do this kind of hybrid cooperation between different clouds, not only the EGI ones, for your use case also. Another one related to the Earth observation, we have this platform that it's running on or partially running on EGI Cloud. It's powered by TerraDue, which is also a commercial company from Italy that has a lot of Earth observation tools. And in this case, the EGI Cloud is used to run systematic processing of Earth observation data for geohazards analysis and monitoring. So TerraDue has this platform, and when they need to run their analysis, they go to the EGI Cloud to do very large batch processing and then come back to their platform with the final results. We also support a lot of the EOSC computing needs, mostly focused on the EOSC hub because we are quite involved in that project. Right now, EGI Cloud is a major compute platform supporting the different EOSC hub use cases. We support the early adopter program, the EOSC hub thematic service, the competence centers, and we collaborate closely with other regional EOSC projects. We are supporting also most of the EOSC Digital Innovation Hub pilot activities, requesting computing resources. And right now, EGI Cloud is the most frequently requested service in the EOSC portal. So we are getting a lot of requests from the EOSC and supporting them for their computing needs. Now we'll move to the EGI Cloud Federation. This will be, I would say, a little more technical, but I will not go very much in depth. It will just give you a glimpse of how the federation works. So federation, the EGI Cloud Federation is what the EGI Cloud Compute Services run on. And it's bringing together different infrastructure as service cloud providers with a set of connectors, which are listed here. So the Unified Authentication Authorization, the Common Virtual Image Catalog, the accounting, information discovery, monitoring of availability and reliability, and some operations coordination to make everything work seamlessly for the users. Here we have the services powered by this federation. So we have the cloud compute that I described it in the previous slides, the cloud container compute that will be featured in another webinar in the future. And we have things like an online storage, training infrastructure, applications on demand, and the notebooks that will also be featured on a webinar next week. So all of those run on top of the EGI Cloud Federation. So what makes this happen? Again, check-in, I mentioned it earlier, but I want to go a bit more from the provider side and more on the technical side. You will have a webinar also on 27th of May, so you can learn more there. But check-in is basically an implementation of the ARC blueprint architecture. That is an IDP SP proxy. That means that it's something that sits in between the users and the different identities of the users and the services. So it simplifies how the different communities and the service provider join the infrastructure. So you only have to interact with one point, which is check-in. And that also gives you consistent and harmonized user identifier with accompanying attribute sets that will specify what the user can do or not. So it's very easy for a service provider to just say, okay, check-in will give me the identity of the user and will give me exactly what are the entitlements of the user, so I can decide whether the user goes in or not into my provider. It's also registered in Edugain as a service provider, complying with REFET's research and scholarship, and certified. This is kind of useful for those people more into the authentication authorization infrastructure world. And we are using OpenID Connect, which is an industry standard, and it's quite powerful and allows you, as we saw before, to interact via the web and via the API or command line access. Then we have the virtual machine image distribution, which is composed of two sites, AppDB with the catalog, and Cloud Keeper, which is the part that does the magic in the providers to have the images there. So in AppDB, you saw before the screenshot of the catalog. It has some nice features. It's not just the metadata, it also does security checks of the images, ensuring there are no known vulnerabilities there with a tool called Secant. And once a community decides an image is good for them, it's available as a HEPIX image list that will be subscribed at the site level using CloudKeeper. CloudKeeper, what it does is checks those image lists and downloads, checks the integrity of the images, and converts it to the right format supported by the provider. So you don't need to worry if one image is a QCO or another is RAW or OVA or whatever. CloudKeeper will take care of make the right conversion to the right format, and has a front-end back-end architecture, so it can be tuned to support different cloud technologies. It's supporting right now OpenStack, OpenNebula, Cinefo, and Amazon AWS, so it can potentially support almost anything, and we are quite happy with this at the moment. Then we have the information discovery, which is what allows the users and everything in infrastructure to understand what are the providers and how they can be used. We have two main parts here. We have GovDB, which is a central web application with some graphical user interface and API that collects the topology, basically which are the providers and what are the endpoints there. And then we have the Cloud Info Provider that it's more about dynamic information, things like what are the images available, what are the VM sites I can use, which are the BOs I can use to log into the provider, etc. And this is a distributed production of information that get pushed to the Argo messaging system that anything or anyone can consume. And it's following the GLUE 2.1 standard. And on top of that, this GovDB and Cloud Info Provider, we have the AppDB information system that consumes and aggregates that information and puts it together to consumption by anyone. It has a REST API and a GraphQL API. And here in this screenshot, I'm just showing one of the entity of the GraphQL API, just to give you an example of things that you can discover. For example, here you say it's a cloud computing service, and here you have things like the number of running VMs or the IDs, the kind of shares, which is what the different communities supported, etc. Besides cloud information, we have accounting that allows you to understand the usage of resources. So it collects, aggregates, and displays usage information across the federation. It's using one standard-based record generated from the different system and aggregates them together, and you can visualize in the portal a screenshot of the portal showing CPU consumption over the last year. We also do monitoring, so it allows you to check if the providers are healthy, ensuring they are live, and providing expected features. So every hour or so, we try to log into the provider and do some basic operations and check if they are working or not. This is powered by one tool called EGI Argo. And with that, we can do automatic generation of reports about the availability and reliability of the providers. So we can check if the SLAs are properly met or not. And again, here is a screenshot of the availability and reliability of one of the SLAs, the Fusion one in concrete. So putting all of this together, we have this figure where we have the architecture. We have in the middle a provider. So this box here in the middle is the provider where they run a cloud management system, and we have a set of tools that interact with that cloud management system to extract information, to extract accounting, or to synchronize the images. And this in turn will interact with other parts of the infrastructure. So the cloud info provider will send information through the Argo messaging system and will be consumed by the AppDB information system. The accounting will send records again through the Argo messaging system and will be consumed by the accounting repository. CloudKeeper will go to the AppDB catalog to get the image list and get the images from repositories. And then we have the check-in part, which is the authentication that is used by users to log into the system, and by the Argo monitoring to monitor the different providers. And Argo uses GovDB as a source of the endpoint topology to understand what needs to be monitored and how. But this is not just all of it. It's not just the technical pieces. We also need the federated operations to make sure everything keeps running as we expect. So we provide a lot of things here. Just to name a few, we have security coordination to ensure if there are any security incidents, they are handled in the proper way. And if there are any vulnerabilities, we are able to handle them in the proper way. We have a common help desk, so users can interact in a single point with all the infrastructure. We provide documentations for users, for providers, policies, procedures, etc. We have coordination campaigns since there is a new release of any kind of software, and the Federated Operations team will make sure that this is properly upgraded everywhere, so they release a campaign for doing that. We have software verification to ensure that whatever software is used in the infrastructure, it meets the quality standards we are used to, and many more things to support proper IT service management following the FITSM standard. I'm almost finishing. I wanted to show which are the current providers of the Federation. We have 22. With some of them just recently joining in the past weeks. They are distributed all across Europe. You have the logos and the location there in the map. And if you are interested in becoming a provider, you are very welcome to join. This will help you to support international communities and will allow you to join like-minded providers to share best practices, experiences, bring requirements to the Federation, and improve it by covering whatever your needs are. If you're interested, the steps are rather simple, I would say. You need a working OpenStack deployment, follow the Resource Center registration and certification procedure, and then do a bit of technical integration, which means configuring check-in so you can accept users from EGI, and configuring these 3 tools that I showed in the previous slide to make the connection with all the Federation staff. So if you're interested, just get in touch with the operation team, describing your setup, and we will get you started. Just some pointers to documentations for user, providers, and use cases. And with this, I'm finished with my presentation, and I'm ready to take some questions.